Okay, so today is chapter 11. Today is chapter 11, and yeah, it's about IPv4, IP address. So IPv4, it's like your passport number or your South African ID or your asylum seeker number, or yeah. Also for cell phones, it's like your cell phone number. So it's a number to identify you. So an IP address is an ID to identify a device in IT. Because in IT, if you want to communicate with someone else, you need a IP or an ID. So these IPs or IDs, we have two ways. We have IPv4 and we have IPv6. We have IPv4, then we have IPv6. So these two are used to identify a PC. So a PC cannot get two IDs. Let's say you cannot have two IDs or two passports. No, you must have only one. So you can have only one IPv4 and only one IPv6, or you can have both on one. One PC can get one, or one PC can get only one of them. Yeah, so it's up to you the way you do config. So now you should know the purpose. I'm going to put in your WhatsApp group to help you for revisions. One second. So I'm going to say um, what is question one? What is the purpose of identifying identify IP IP before addressing? Yeah, so the purpose of IP is to identify someone or a cell phone or a device. Open my packet tracer. So then we have two types of IP addresses. I'm going to answer. What are the two types? The two types of IP addresses. So we have IPv4 and IPv6. So you see, when you have some devices, a PC, all these things in IT, we need what? All any end device, we need to get identified. So we need IPv4. So we'll see how we can do that. So, you also know that IPv4 is dealt, we do it via the router, not the switch, and it's also called a logical address. So a device has a logical address or IPv4 managed by the router, and also a physical address that never change, that is managed, or MAC address that is managed by the switch. So this one you should know now. Should know now. Okay. So physical address, MAC address can be changed. We change. We do it on the router there. Managed by router. Managed by by switch. Okay, so IPv4 addressing. Any device needs two addresses, the physical address that you know, the logical address, and for logical address, we have two, IPv4 and IPv6. So this is an example of IPv4. It's four blocks. One, you see, one block, two, three, four. This is how it is. And also, this is an example of IPv6. IPv6 is 8 blocks with hexadecimal numbers. 1, 2, 3, 4, 5, 6, 7, 8. So for those who did IT essentials, we did cover a bit that already. Yeah, so these are some addresses a PC can get. OSI model, you should know now, physical layer data link. Now, all these IP addresses are at the network layer. So now, to classify IPv4, we have three classes. Class A, Class B, Class C. We're going to check that. I'm putting your. What are the three classes of IPv4? Okay, so now to assign IP addresses, we can assign manually. The IT guy, sorry, the IT employee enters the IP address. Like here, myself, I can open it, and myself I can type, you see, manually. You see. So we call it static IP. Or this device can get a IP automatically via a server. A server is a device that provides services. One of these services is to assign automatically IP address to people, to devices. You see, DHCP. We see that it will get automatically IP according to your configuration. So how to assign IP addresses, you know. Okay. So now we have a difference between private IP and public IP. So we did all that in IT Essentials already. I'm putting your questions. So you should know that a private IP cannot go to the internet. We say non-routable. We cannot use it. We use it for demonstration for labs. Like here, if you want to play around with some IPs, we use a private. Now, if a device needs an IP to go to internet, that device needs a public IP, and we purchase that via your internet service provider. Let me check here, cost, public IP South Africa. So the cost of public address in South Africa to range from 50 to 100 rand per month. Listen. So if you want to buy, you buy via an ISP, and you pay per month. So because the public IP addresses are expensive, we need to find plan B to allow anyone to go to internet. So this one we'll do at CCNA3 with the last part of our CCNA. We call it NAT, Network Address Translations. It means we're going to translate, to change our private to a public. Our private to a public for the device and to go to internet. So it's something that will be done at the end of CCNA. So network address translations, private IP addresses are changed to public to go to the internet. So you can have one private to be changed to one public, 1-to-1. We'll check that later. Or everyone can use a pool. So there are many ways of doing the translations. Then there is something called subnet mask. So it's like you're a student, and we need, if you show your student card, we should get a second option to know your country of origin. So you can show your student number. They're going to always to ask you country of origin. Ivory Coast, France, Zim, DRC, Burundi. So a subnet mask is a number that follows a IP. So anytime you have an IP, we need a subnet mask. It's compulsory. So that subnet mask will identify this IP belong to which network group, or this student belong to which faculty, or this student belong to which university. You see. So it's a number to identify in which network this IP belongs to. So we can do IP /24 and 24 once. We'll do that later. Or the IP, and you convert always in decimal. We did it now. When you have 24 ones, 1, 1, 1, 1, 1, 1, when you convert, it gives you this. Yeah, so it's so you identify. So definition of IP is a number to identify device or also an interface. Sorry, of a router. You know an example of IP, and we have three classes and how to identify each of them. Let me also add in your uh, in the Mhm. You can read this one while I'm busy. Mhm. Okay. So we have three classes of IP addresses: class A, class B, class C, like cell phone numbers. We organize them. This number belongs to cell C, this number belongs to Telcom, this one belongs to MTN. You see. So to identify a class A, the first block here, you can see, must fall between this range. If the first block starts between 0 and 126, like this one, it means it's a class A. For class B, the first block should be between this 1 to 8, like this one. You see, this one falls between this range, so it's a class B. How to identify a class C? The first block, the range should be between this now. So this one is extremely important. So have a look and we continue. Yeah, I'm getting some questions. Yeah. Okay. So if I ask you, so if a IP start with 127, it means it's a loop back address. It's to test your network interface card if it's working very well. So if I tell you guys this address, it belongs to which class? What is your answer? Yes?
Yeah, I think it's in the first class A
Yeah. Why?
because it's in the range of 66 to 120, 126.
Very good. You see the first block, 100, it falls in this range. So it means this IP is a class A. Very good. So now if I say 18 here, for example, what address is that?
That's the second, which is class B.
Yeah, so it's very good. You see, 180, the first block falls in this range. It means it's a class B. So this is how we identify IP addresses. So you know the difference between public address and private address. Now the range for private, here I made a mistake. This one very important. You can check that. So if you have a class A IP that start with 10, it means it's a private. We cannot use it to go to internet. When you have class B, if it start with 172.16 until this range, any of these addresses is a class B, so it's a private class B addresses we cannot use to go to internet. And the same thing for class C. So this one is very important. Please check that. So this one is also something that you should know. We ask a lot for exams, job interviews. Remember, you are a network engineer or a network doctor. So you know the network, how to build, how to change, how to fix, how to troubleshoot. And this same training is the same in America, Canada, Europe, Asia, anywhere in the world. Same training, same certificate, same knowledge. So please take it seriously, it will help you. So now when it comes to subnet masking, so when an IP address is assigned to a device, we always add a subnet mask. An IP doesn't come alone. It always comes with a subnet mask. So the subnet mask is used to determine the network in which the device belongs to. And so it's like Feli is a businessman. He bought a house, one big house on one place, and he want to rent. He's going to divide in smaller rooms. You see? So as soon as he start dividing in smaller rooms, each tenant need to get identify the room number. John, yeah, your tenant John, you belong to which room number? So the room number is a subnet mask. It will identify the user in which room the tenant, which room you are renting. Should be the same thing. Very important to know. All these things, if you need more info, Google it, go to YouTube, compile your own summaries. So default subnet mask. So class A, the default is /8 or 255. Why 8? Because you see, the IP has 4 blocks: 1, 2, 3, 4. So class A focuses always on the first block. So if all the first block, everything is 111, we have 8 ones. That's why we say /8 or so the default subnet mask for class A, this is it. And the default for class B we focus more on the first two blocks. So if you put all ones, 8 plus 8, we say slash 16. Or if you convert all of them in decimal, is 255.25.255. For class C, we focus more on the first three blocks. The first block is for a big network. Now, anything else here we can assign to a host. We're going to do later on some packet tracer stuff. So the first three blocks, we convert all of them in ones. The network part has slash 24. So this is what we call default subnet mask per class. So check that and we continue. So all these things. So examples, a class A, you see 20 equals. So when you add an IP with a default subnet mask /8 or the same address, but if you convert the 8 ones in decimal, see. So some type of question papers, you'll see this type of IP /8 or this. Same thing for B and C. So you can also check that, very important. Okay, we're going to do two other things. Then next time we'll do something called subnetting. Yeah, so let's go step by step. Okay, yeah, this one I'm going to send to you in the WhatsApp group for you to. Yeah, I'll send it to you via WhatsApp group. How to assign IP addresses manually or automatically via DHCP server. So this server can assign IP address, subnet mask, default gateway, and other configuration information according to what you configure. So very important this side. So check again. Okay, the last part that we will be doing the next time is called subnetting. Add in your WhatsApp group. So subnetting is to divide a network in smaller pieces. So let's say you're renting a big room, very big. So if you don't divide, and that room has what we call the default subnet mask. If you don't divide, you only have one room. it will default subnet mask. As soon as you start dividing in your that big room in smaller rooms, we say you're subnetting or you're dividing. For example, here, you're dividing your room in 4 smaller rooms to rent to people. Room 1 will be for Denise. Uh, room 2, Sangani. Room 3, room 4. So subnetting is dividing your one big bedroom in smaller rooms and to rent to people. So when you divide your big room in smaller, we see you do subnetting. So when you have a network and you divide in smaller networks, we say you do subnetting. And it's what we're doing next time. So I'll just show you an example, and this one we'll be doing next time. For example, you have this network and slash 25, and we ask you in which room, and for example, we say Sangani, and we ask you in which room it belongs to. Is it to room 1, room 2, room 3, room 4? So there are some steps to identify. So if they give you such IP, they ask you in which network or smaller networks this IP belongs to. In which smaller network? In which smaller network this IP belongs to. And when you find a smaller room inside, you should know the first valid IP you can assign to someone, the last valid, and a broadcast. So it's something we'll be doing next time. But for now, I try to show you. So if you want to find each of them, we need some steps. So step one, some guidance. Step one, identify the class of that IP. So you see 192, it's class C. You see. Now, step number 2, identify the default subnet mask for class C. We know that is slash 24 or all ones here. See, 24 ones. Remember the default subnet mask now? For a class C is slash 24 or all 25525. Then, after you identify the class, you identify the default subnet mask. Now you check the question here. This IP we say is slash 25. It means from our standard 24, 1 has been added. So you do bit borrowed. 25 minus 24 is 1. So you see, before you had your 21, your 24 ones, and now you did borrow 1 extra bit from the host section. That's why you have now 25. You borrowed 1. So if you borrow 1, it means you have divided your network in smaller networks. How many are they? How to identify the number of smaller network? So we do a formula. No worries, and this one we'll do next time. It's just to show you once. We did 2 to the power of bit borrowed. So 2 to the power of 1 because I borrowed 1. If you do mathematics, 2 to the power of 1 is 2. So it means we have 2 smaller networks. How to find these 2 smaller networks? Because it's class C, the first 3 blocks never change. You see from your question, 1, 2, 3, the first 3 blocks for a class C never change. Remember here, class C, the first 3 blocks are from the network, it doesn't change. For class B, the first 2 blocks never change. Class A, the first block never change. Then you add the first 3 blocks. Now, to find with the first one, you do 0, it starts with 0. And the second one is 1 to 8. Why 1 to 8? Because if I borrow only 1 bit, I do my table 128, 164, and I add that number in here, you see. And I check the last one. This is the one. It falls in 128. That's why I put it here. So my first smaller network is here. My second smaller network is here. So 128 is called the magic number. It means when I check where the bit borrowed are, I check the last one from left to right. Left to right, this is the last one. If it was 1 1 like that, my magic number, you see 1 2 left to right, this is the magic number 64. You see? So we'll do that next time. So when we find each smaller network, we need to find the first valid host you can assign to a PC, the last valid host, and the broadcast. So we'll do that next time. To find the broadcast, you do the next network minus 1. See? To find the last host you can assign, you do the broadcast minus 1. And to find the first valid host, you do the network plus 1. See? This is how it works. And we'll be repeating next time. So this is how it works. Now, if you go back to the question, this IP 10.12, you can see that it belongs to between 126. So it means this is the network it belongs to. Because the first network goes from 10.1 until 10.126. So 10.12 falls in this range. So it means it belongs to this network. So it's something that we'll be doing next time, next Tuesday. So let us stop here for today. At least we did cover the big picture. The next time we'll be doing that. So I'll send you that file for you to study during the weekend. Any questions? So here is page 44. Page 48. Let me continue. Page 48, it's fine. Page 47. So go on top. Page 47. Using page in this page is what? 43. So page 42. No, 43. Okay, page 43 to 49. Yeah, so that's all for today. So I'll send you the recording tomorrow morning. Oh, why is it took this one? No, it didn't. 42, 43, page 43. To 49, 43 to 49, 43 to 50. Okay. Okay, it's fine. Yeah. So I'll send you that one. I'll send it to your WhatsApp group. Okay, thank you very much, guys. Please study. Study. CCNA is not difficult. It is to study a lot, doing the assignment a lot. That's all. If you have time to study, you pass and become network engineer. It's a very, very well-known certificate. You can work anywhere in this world. So please take it seriously. It will help you. Thank you very much, guys, and have a good evening. If you have questions, WhatsApp group is there, or you can call me or contact me. Thank you, guys. Thank you. Have a good evening.